Time for some practical application questions, right? So here are some problems involving radical equation. It says an engineer has to design a roller coaster. Wait a second. Yeah, I guess there has to be somewhere in the world an engineering class that designs roller coasters. I could just imagine the graduation ceremony. Graduation ceremony would be when you design your roller coaster and you throw somebody on there and you graduate whether or not they puke or not. Graduation is based on puking. Oh my goodness, I think that would be so much fun. Okay, I'm distracted here. All right, so an engineer designs a roller coaster that involves a vertical drop section. Okay, so we got to have a vertical drop section. Vertical drop usually means some sort of distance. All right, just below the top of the ride. So what we've got here is we've got the top of the ride here, and we're going to go down like this. That would probably be your vertical drop section right there. Okay, now she uses the equation v equals 2. Now, if you know a little bit about Science 10, you know that V stands for velocity, A stands for acceleration, and D stands for distance. And they're using this equation to model the velocity. Oh, there you go. V in feet per second. Oh, that's interesting. That's very American. Of the ride's cars after dropping a distance. Oh, there it is. Just like we thought. Distance is D with an initial velocity. Oh, so you got a starting velocity because you're not just going to stand here. This cart that's here on this roller coaster isn't just going to be sitting there. It needs a little bit of momentum to get it going down this hill, to get over that little hill. Okay, so in feet per second at the top of the drop and the constant acceleration of A. Yes, so just like we did before. This is our final velocity. There's our initial velocity, acceleration due to gravity, and there's our beautiful distance. Okay, so here we go. Let's keep on going. It says the design specifies that the speed of the ride's cars must be 120 feet per second. So in other words, by the time it hits the bottom here, you got to be going at 120 feet per second. So if you think about that, that's the final velocity, okay? Because it's at the bottom, right? If the initial velocity of the coaster is 10 feet per second, so that's at the top, so that's our initial, that would be this V sub zero, which we call V naught, okay, is 10. This is our final. There's our V. And the acceleration due to gravity. Oh, there it is. There's the Canadian influence. There's the A. My question is, what's going to be the vertical drop, which is this D? Okay, that's not so bad. I can do this actually quite nicely algebraically. So look at the formula. V equals to, right? The square root. There's your radical. V naught squared, right? V naught squared, right? Plus 2AD. Let's start throwing some numbers in there. Here we go. Your velocity is 120 at the bottom. Your initial velocity here is 10. Okay. All squared. Plus 2 times the acceleration, which is 32. And you have to solve for good old D. Oh, that's not so bad. That's actually kind of easy to do. So basically what you need to do then is start solving. First thing I would do is, since this whole thing is under the radical sign, I'd square both sides. So square this side, square this side. Now 120 squared. Now 12 squared is 144. I know that. And you got 2 extra zeros, so I bet you that's what that equals to. You can go check it on your calculator, but I'm pretty sure that that's right. Leaving you 10 squared, which is 100, plus 2 times 32 looks like 64. D. Oh, that's just simple algebra from that point. Minus the 100 from both sides. Real nice. That's gone, giving you 14300 equals to 64D. Okay. Divide by 64, divide by 64. Throw that on your calculator. I'm going to cheat a little bit because I already did this. It's 223 feet is your distance. And don't forget to tell me the units, because distance in this particular question is in feet. Now, how can you make sure that you've done this right? Well, real simple. Throw in your calculator. go back to this question right here. And if you look, we can start this right here. Start putting the numbers in again. There's 120. This equals to the square root. There's your radical. Now, start figuring this out. That's 10 squared. That's just 100. That's plus 2 times 32d. So that's 64d. Well, look how pretty that is. Use this as your y1. Use this as your y2. Now watch your window settings, because if that's y1, you're going to have to blast those window settings to at least higher than 120. Probably 130, 140 will do fine. And this guy here, well, think about it. You know your answer is going to be 223 feet, so you know that your x value is going to be somewhere over 233. So you might want to go a window setting of a y max to be somewhere around 130 and an x to be somewhere around x max to be somewhere around probably 250, just so that it fits pretty into the graph. Well, that's what I'm going to do next. See how the algebra can actually help you out graphically. Well, that's pretty cool. Okay. So I put the values into the calculator. There's your y1 at 120. There's your y2 at 100 plus 64x. And remember, before you do anything, because if you don't, look what happens when I zoom standard this. Look, that's what you get. Well, where's the intersect? Where's the rest of the graph? This is where, again, you have to be a bit smart here, and you have to kind of pre-plan. We said our x minimum, because our x value for this, our solution, is 223 feet. Let's put this out at about 230 feet, because then we know that the graph is within this parameter. Okay? Look at the y max. Y max we have here at 120. So maybe 150 for that would probably work quite nicely. So that both graphs should be somewhere in there, and you should see the intersection point quite nicely. Don't worry about the scales. I've never worried about them at all. So you're going to get something that looks like that. Then, of course, there's your graphical solution. Go second calc, find me that intersect 5, enter, enter, enter. And look at that. There's that 223, just like we predicted. Nice, sweet, easy question, beautiful answers, and away we go.